friends. Today we are discussing about the various components of IC engine. In previous session, we covered the piston, then connecting rod, then piston pin, piston rings, piston block, that components. So now we will cover the all remaining components. So next component of IC engine is a crankshaft. So the function of the crankshaft is it converts the reciprocating motion of the piston into the useful rotary motion of output shaft with the help of connecting rod. So in crankshaft of single cylinder engine, there are a pair of crank arms and a balance weight. The balance weights are provided for static and dynamic balancing of the rotary system. The crankshaft is enclosed in the crankcase. So the materials used for manufacturing of the crankshafts is medium carbon steel alloy having a 0.25 to 0.45% of carbon. Then manufacturing method is generally forging process. Then the properties of the material used for crankshaft is it has a high fatigue strength and it has a high hardness. So because of these two good properties, the medium carbon steel alloy is the best suitable material for manufacturing of the crankshaft. So the main function of the crankshaft is to convert the reciprocating of motion of the piston into the useful rotary motion of the output shaft. So this is the diagrammatic representation of the crankshaft. So here the big end of the connecting rod is connected and the reciprocating motion of the connecting rod or piston is going to convert it into the rotary motion by using this crankshaft. Next one is a element or component is a camshaft. So the camshaft and its associated parts control the opening and closing of the two valves, that is a inlet valve and exhaust valve. The associate parts are push rod, rocker arms, valve springs, and tappets. So the shafts are also provide the drive to the ignition system. The camshaft is driven by the crankshaft through timing chain or a timing gears. So the materials for the camshafts are, it is manufactured with the help of chilled cast iron material with 1% of chromium. Then billet steel can also be used as a material for camshaft. Then the properties of the these materials are, it has a high volume production, have a good wear resistance, high quality camshafts or low volume production. So because of this property, these chilled cast iron or billet steel is used as a material for the manufacturing of the camshafts. So this is the diagrammatic representation of the camshaft. So here you can see this shaft is called as a camshaft. Then cams, these are made as an integral part of the camshaft and are designed in such a way that it will open the way to open the valves at the correct timing and to keep them open for necessary duration. So this is the diagrammatic representation of the cams. It consists of a heel and nose. So this portion is called as a nose and this portion is called as a heel. Then the length between the end of the heel is called as a base circle. Then this is called as an opening ramp. This is called as a closing ramp, and this will be the axis, or it is also called as a lobe center line for the cams. So this is the three-dimensional view of the cam. Next component is inlet and exhaust valves. Valves are commonly mushroom shape, poppet type. They are provided on the cylinder head for regulating the charge coming into the cylinder inlet valve and for discharging the product of combustion exhaust valve from the cylinder. So inlet valve is used for the charge coming into the cylinder, and exhaust valve is used for discharging the product of combustion, that is the burn gases, to the atmosphere from the cylinder. Then the materials for inlet and exhaust valves are used as a stainless steel, titanium or Inconel. Then it has a high temperature, oxidation, corrosion resistance property. Now this is the diagram of the inlet valve, and this is the diagram of inlet or intake valve and exhaust valve. Then this is also a diagrammatic representation of the valve mechanism. So here a spring is provided, then it will be attached with the camshaft, and cam is there. So once cam gets rotated, the inlet and outlet valve gets actuated or work depending on the type of the stroke. So during the inlet stroke, inlet valve will get open and the entry of the air fuel or charge will be coming inside the fuel. Then there will be the different strokes inside the cylinder for the piston, and after that, once all the strokes are completed, for the exhaust stroke, the outlet valve will get open and burn gases are thrown out to the atmosphere through the silencer mechanism. Next device is the spark plug. So it is the component to initiate the combustion process in spark ignition engines, that is in SI engine, and usually located onto the cylinder head. So this is the spark plug device which is used for the initiation of the combustion process in spark ignition engine, that is nothing but in SI engine or in petrol engine or in gasoline engine. The spark plug is used to ignite the fuel. So it is usually located on the cylinder head. Next one is a fuel injector. So it is also a component to initiate the combustion process in compression engine, that is nothing but in diesel engine, and usually located on the cylinder head. So here the position is same for spark plug and cylinder head, but the objective is different. The objective is also same, but if it is a SI engine, then there will be the use of the spark plug, and if there is a compression engine, that is nothing but if diesel engine is there, then there will be a use of the fuel injector. So main difference between diesel engine and petrol engine is that the spark plug is used in the SI engine, that is in petrol engine, and in CI engine or diesel engine, fuel injector is used to initiate the combustion process. Then this is also a diagrammatic representation of the fuel injector or fuel pump or fuel. So entry of the fuel will become from the fuel tank. Then fuel filter is there. Then solenoid valve is there. Valve spring is provided. Then plunger is there. Then spray tip is there. That is the nozzle is there. And atomized fuel. So the required fuel for the combustion is ready, and the initial ignition will be start once this atomized fuel is injected through the injector. So this is the sectional or cross section view of the fuel injector. The next one is a crankcase. So it is the bottom part of the engine block. So you can see here the bottom part in the engine is a engine block, or it is a crankcase. For that is nothing but top portion is the cylinder head and bottom portion is called as a crankcase. It holds the crankshaft of the IC engine and also serves as a sump for the lubricating oil. So here you can see the hollow portion is there. Here also hollow portion is there. So in this hollow portion, the lubricating fluid, that is a lubricating oil, is kept, which is acts as a lubrication, acts as a lubricant for the during the working condition of the engine. Then next component is a flywheel. It is a big wheel mounted on the crankshaft, whose function is to maintain its speed constant. It is done by storing the excess energy during the power stroke, which is returned during the other stroke. So this is the wheel you can see called as a flywheel, which is used for the storing the excess energy during the power stroke and provide the required energy during the another stroke. Then the material for flywheel is cast iron or steel. So these are the two commonly used material for manufacturing of the steel. So here we completed the all the types of the component present in the IC engine. Thank you for watching.